Good evening, everyone. I hope my voice is audible. Yes, Manjunath, good evening. Kavana, good evening. So, dear students, I request you that please don't chat unnecessarily in the chat box. If you have any doubts, you can ask in the chat box. Okay, otherwise, don't message in that group. So, that is my humble request. So, already we have completed the two classes on this chapter, that is acids, bases, and salts. Here, so what are acids? What are the chemical properties of acids, and bases? What are the chemical properties of bases? That already we have completed in the last chapter. So today we are going to discuss the last part of this chapter, that is about the salts. Already we have started the discussion on the salts, alva. So I hope acids bases ಬಗ್ಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. So let us move to the next part of this chapter, that is salt. So what is the pH of the salt, how salt is obtained, how we can decide the pH of the salt. So that we have completed in the last class. So common salt, so that is example for the salt, that is NaCl, sodium chloride, that is the common salt, and it is raw material. This sodium chloride, it is used to obtain the different chemicals like baking soda, washing soda, bleaching powder, and many other compounds are obtained by this by using the common salt. Common salt ಅನ್ನ raw material ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇರಬಹುದು, ಅವ್ರ ಬೇಕಿಂಗ್ ಸೋಡಾ, ವಾಷಿಂಗ್ ಸೋಡಾ, ಬ್ಲೀಚಿಂಗ್ ಪೌಡರ್. ಸೊ ಇದೆಲ್ಲದಕ್ಕೂ ಕಾಮನ್ ಆಗಿ ರಾ ಮಟೀರಿಯಲ್ ಯಾವುದು? ದಟ್ ಈಸ್ ದ NaCl, common salt. Okay, so first thing, sodium hydroxide. How sodium hydroxide, that is NaOH, how NaOH is obtained chloride as a raw material. ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಅನ್ನ ರಾ ಮಟೀರಿಯಲ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಹೀಗೆ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾರೆ ಅಲ್ವಾ. ಸೊ ದಟ್ process commonly called as chlor-alkali process. So why it is called as chlor-alkali process? So let us see the experiment related to this. Yes, this is the experiment. Already we have completed this, right? So ಇದನ್ನ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾನು ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ದೇನೆ, ಬಟ್ just recall this. Here, the sodium chloride aqueous solution of sodium chloride is used. NaCl is used. That is also called as brine solution, right? It is also called as brine solution. Here, two electrodes are used. That is anode and the cathode. So positive and the negative electrodes. So when the current is passed through this electrode, here the sodium chloride that split into sodium plus Cl minus. Sodium chloride that split into sodium and Cl minus. And again, water. So water split into H plus and OH minus ions. Okay. So here the sodium ions and OH minus ions, Na plus and OH minus ions combine to form the NaOH, sodium hydroxide is formed, right? Then here H plus ions and Cl minus ions at the anode and cathode, they form the chlorine and the hydrogen gas. Illi chlorine ಕ್ಲೋರಿನ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅನ್ನ ರಿಲೀಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಪ್ರೊಸೆಸ್ not only sodium hydroxide, so along with the sodium hydroxide, chlorine is also formed. Okay, yes, dear students, am I audible properly? Please comment in the comment section. Audible idya ನನ್ನ ವಾಯ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ? ಓಕೆ, ಐ ಹೋಪ್ ನನ್ನ ವಾಯ್ಸ್ ಆಡಿಬಲ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. ಓಕೆ, ಎಸ್, ಇನ್ ದಿಸ್ ಪ್ರೊಸೆಸ್ ಕ್ಲೋರಿನ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಆರ್ ಫಾರ್ಮ್ಡ್. ಸೊ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕ್ಲೋರ್ ಅಲ್ಕಲಿ ಪ್ರೊಸೆಸ್. ಇಲ್ಲಿ ಕ್ಲೋರ್ ಅಲ್ಕಲಿ ಪ್ರೊಸೆಸ್ ಅಂತ ಕರೀತಾರೆ. ಗೊತ್ತಾಯ್ತಾ? Why it is called as a chlor-alkali process? Because alkali, sodium hydroxide, that is the alkali, and chlorine, that is the gas. So both chlorine and sodium hydroxide is formed. So it is called as a chlor-alkali process. Okay. So let us see how bleaching powder is synthesized using the sodium chloride as a raw material. Okay, chlorine is produced during the electrolysis of aqueous sodium chloride, that is the brine solution. So ನಮ್ಗೆ ಗೊತ್ತಿದೆ ಇಲ್ಲೇನಾಗಿದೆ, ಕ್ಲೋರಿನ್ ಪ್ರೊಡಕ್ಷನ್ ಆಗಿದೆ ಅಲ್ವಾ. ಸೊ ಕ್ಲೋರಿನ್ is produced Cl2, that is in the process of, that is in the chlor-alkali process. Already chlorine is produced, and for the production of this chlorine, sodium chloride brine solution, sodium aqueous sodium chloride solution is used, right? So here also the sodium chloride, that is the sodium chloride is the raw material. Okay, then this chlorine gas is used for the manufacture of bleaching powder, and bleaching powder is produced by the action of chlorine on dry slag lime, that is calcium hydroxide. Okay, let us see how bleaching powder is formed. This reaction is very important. When chlorine gas is passed through the calcium hydroxide, that is the dry calcium hydroxide, then calcium oxychloride, CaOCl2. Calcium oxychloride is formed along with the water. This calcium oxychloride, that is the chemical name. Okay, so that is the scientific name. Calcium oxychloride. Okay, calcium oxychloride, common name is bleaching powder. So important ಇದೆ, ನಿಮಗೆ MCQ ದಲ್ಲಿ ಕೇಳ್ತಾರೆ. Common name of calcium oxychloride, that is bleaching powder, or bleaching powder also called as calcium oxychloride. And this reaction, that is very important. Okay, yes. So for the production of bleaching powder also, chlorine is used, and that chlorine, that is produced by the chlor-alkali process. So sodium chloride is the raw material. Okay, let us move to the next slide. Yes, this is the bleaching powder. So common ಆಗಿ bleaching powder ಅಂತ ಏನ್ ಕರಿತೇವೆ, ಸೊ ಅದು ಈ ರೀತಿಯಾಗಿರುತ್ತೆ ಅಲ್ವಾ. What are the uses of the bleaching powder? Very important for your exam. Very important for your exam. What are the uses of bleaching powder? For bleaching cotton and linen in the textile industry, for bleaching wood pulp in the paper factories, and bleaching washed clothes in the laundry. So common ಆಗಿ ಇದನ್ನ ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಕಾಟನ್ ಮತ್ತೆ ಲೈನನ್ ಅನ್ನ ಬ್ಲೀಚ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಮೀನ್ಸ್ ಅದನ್ನ ಅದರಲ್ಲಿರುವಂತಹ ಬೇರೆ ಬೇರೆ ಕಲರ್ಸ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಿ ಅದನ್ನ ಬ್ಲೀಚ್ ಅಂದ್ರೆ ಅದನ್ನ ಇನ್ನು ವೈಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಅಂಡ್ ವುಡ್ ಪಲ್ಪ್ ಅನ್ನ ಬ್ಲೀಚ್ ಮಾಡಿ ಏನ್ ಮಾಡ್ಬೇಕು, ಪೇಪರ್ ಅನ್ನ ಪ್ರೊಡಕ್ಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಪೇಪರ್ ಫ್ಯಾಕ್ಟರೀಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ದೆನ್ as an oxidizing agent in many chemical industries, it is also used in many chemical industries, and to make drinking water free from germs, to make the drinking water free from the germs. So that is also very important use of the bleaching powder. Okay, so these are the uses of the bleaching powder. I hope this concept is clear. Okay, yes. Next is baking soda. For the production of baking soda is also raw material used, that is the sodium chloride. Not only sodium chloride, along with the sodium chloride, water, carbon dioxide, and ammonia that is used. Okay, baking soda is commonly used in the kitchen for making the tasty and crispy bakoras. So this baking soda, the name itself says that it is used in the baking industries for the baking of some food items, right? Sometimes it is added for the faster cooking. The chemical name of the compound is sodium hydrogen carbonate, NaHCO3. Sodium hydrogen carbonate, NaHCO3. That is the sodium hydrogen carbonate. It is produced using the sodium chloride as one of the raw material. So, ಇಲ್ಲಿ ನೋಡಿ. Yes, uh, this reaction, sodium chloride, when it react with the water, carbon dioxide and the ammonia, ammonium chloride along with this baking soda. What is the chemical name of the baking soda? Please write down in the comment box. What is the chemical name of the baking soda? What is the chemical name of the baking soda? Please write down in the comment box. Yes, that is sodium hydrogen carbonate. Anybody? Yes, the following reaction takes place when heated during the cooking. So when it is heated during the cooking, sodium hydrogen carbonate, when it is heated in the cooking, it produces sodium carbonate, that is Na2CO3 plus water and carbon dioxide. And this carbon dioxide that is responsible for the that fluffy nature of the food items. Common ಆಗಿ ಇದನ್ನ ಕುಕಿಂಗ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಲ್ವಾ? ಸೊ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ದಟ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಈಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ದಟ್ that fluffy nature of the food items. Okay. Then uses of the baking soda. Yes, what are the uses of baking soda? For making baking powder. Baking powder is prepared by using the baking soda, which is the mixture of baking soda and mild edible acids such as tartaric acid. Baking powder. So what are the constituents of the baking powder? That is baking soda and tartaric acid. Okay, baking soda and the tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. When baking soda that is mixed with water, so when it is heated or when it is mixed with the water, carbon dioxide and water, so that are the major constituents produced. The carbon dioxide produced during the reaction can cause the bread or cake to rise, making them soft and spongy. So common ಆಗಿ ಬೇಕಿಂಗ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಲ್ವಾ ಇದನ್ನ, ಕೇಕ್ ಮಾಡಕ್ಕಿರ್ಬಹುದು ಅಥವಾ ಬ್ರೆಡ್. ಸೊ ಇದನ್ ಸ್ಮೂತ್ ಅಂಡ್ ಸ್ಪಾಂಜಿ ನೇಚರ್ ಹೇಗೆ ಬರುತ್ತೆ? ದಟ್ ಈಸ್ ಹೋಲ್ಸ್ ಅಂಡ್ ಆಲ್ ದಟ್ ಈಸ್ ಬೈ ದ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ವೈಲ್ ಹೀಟಿಂಗ್. ಸೊ ಅದನ್ನ ಹೀಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ಆ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಏನ್ ಮಾಡುತ್ತೆ? ದಟ್ ವೆನ್ ಇಟ್ ಈಸ್ ರಿಲೀಸ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ ದ ಹೋಲ್ಸ್. ಆ ಹೋಲ್ಸ್ ಫಾರ್ಮೇಶನ್ ಆಗೋದ್ರಿಂದ ಏನಾಗಿರುತ್ತೆ? ಸೊ ದಟ್ ಮೇಕ್ಸ್ ದ ಬ್ರೆಡ್ ಅಂಡ್ ಕೇಕ್ ದಟ್ ಈಸ್ ಸಾಫ್ಟ್ ಅಂಡ್ ಸ್ಪಾಂಜಿ. Sodium hydrogen carbonate is also ingredient in antacids. Antacids means that is used against the acidity. So ಬಾಡಿಯಲ್ಲಿ acidity ಆದಾಗ, stomach acidity ಆದಾಗ, so that is used. Being alkaline, it neutralizes the excess acid in the stomach and provides the relief. It also used in soda acid fire extinguisher. Fire extinguisher ಕೂಡ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Do you know another example for the antacid? Anybody? Please write down in the comment box. Do you know any example for the antacid? Sodium hydrogen carbonate, that is baking soda, is one of the example. Do you know any other example that we have discussed in the last class? Yes, anybody? Yes. Chemical name, I'm asking, not Eno. Yes, somebody, milk of magnesia. Atish, yes, very good. Milk of magnesia. Very good. That is also used as an antacid. Very good. Yes. Milk of magnesia. Magnesium hydroxide. MgOH twice. Magnesium also used as a antacid, okay, along with the baking soda. Baking soda is also used. And one more example is milk of magnesia. Very good. Next one, washing soda. Another example, so that another material that is used, that is prepared by using the sodium chloride, that is the washing soda. That is, the chemical formula is Na2CO3 10H2O. So sodium carbonate can obtain by, it is, the chemical name is sodium carbonate. Washing soda is sodium carbonate, and baking soda is sodium hydrogen carbonate. Here it can be obtained by heating baking soda, recrystallization of sodium carbonate giving the washing soda. So what is this recrystallization of sodium carbonate? This sodium carbonate, when it is treated with the water, it forms the, so when it is recrystallization, so this Na2CO3 that is prepared by the sodium hydrogen carbonate, right? NaHCO3, when it is heated, it forms the Na2CO3. Sodium carbonate formation ಆಯ್ತು ಇಲ್ಲಿ ಅಲ್ವಾ? Sodium carbonate formation ಆಯ್ತು, but it is not used as a washing soda. When it is treated with the water, that is 10H2O, recrystallization. Again, when it is treated with the water, it forms the washing soda. The chemical formula of washing soda, that is Na2CO3, 10H2O. Okay. And sodium carbonate and sodium hydrogen carbonate are as chemicals for many industrial processes as well. Okay. How washing soda is prepared? So that is the recrystallization of sodium carbonate gives the washing soda. Okay. Then what are the uses of washing soda? So washing soda uses ಏನು ಅಲ್ವಾ? So that is the uses of these all salt, that is very important. ಈ salts uses ಏನಿದೆ ಅಲ್ವಾ? ಬೇಕಿಂಗ್ ಸೋಡಾ ಇರ್ಬೋದು, ವಾಷಿಂಗ್ ಸೋಡಾ ಇರ್ಬೋದು, ಬ್ಲೀಚಿಂಗ್ ಪೌಡರ್ ಇರ್ಬೋದು. So these all are very, very important. Sodium carbonate, that is the washing soda, is used in glass and soap industries, commonly used in the glass, soap and paper industries. It is used in the manufacture of sodium compounds such as borax. Borax ಅನ್ನ ಯೂಸ್ ಮಾಡಕ್ಕೂ ಕೂಡ, ಪ್ರಿಪೇರ್ ಮಾಡಕ್ಕೂ ಕೂಡ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then sodium carbonate can be used as a cleaning agent for domestic purpose. So you know that this washing soda, that is the cleaning agent for the domestic day-to-day life. In our day-to-day life, it is used for removing the permanent hardness of the water. So permanent hardness, very important. Germs ಅನ್ನ ರಿಮೂವ್ ಮಾಡೋದು ಬ್ಲೀಚಿಂಗ್ ಪೌಡರ್, ಅಂಡ್ ಪರ್ಮನೆಂಟ್ ಹಾರ್ಡ್ನೆಸ್, ಹಾರ್ಡ್ ವಾಟರ್, ಕಾಮನ್ಲಿ ಹಾರ್ಡ್ ವಾಟರ್ ವಿಚ್ ಕಂಟೈನ್ಸ್ ದ ಕ್ಯಾಲ್ಸಿಯಂ ಅಂಡ್ ಮೆಗ್ನೀಷಿಯಂ ಅಯಾನ್ಸ್ ಎಕ್ಸೆಸಿವ್ಲಿ. ಕ್ಯಾಲ್ಸಿಯಂ ಮತ್ತೆ ಮೆಗ್ನೀಷಿಯಂ ಅಯಾನ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಎಕ್ಸೆಸಿವ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಹಾರ್ಡ್ ವಾಟರ್, ದಟ್ ಈಸ್ ನಾಟ್ ಸುಟೇಬಲ್ ಫಾರ್ ಯೂಸ್. So this permanent hardness of the water, that is removed by the washing soda. Okay, so these are the uses of the washing soda. So one of the very important, very, very important, I repeat once again, so important for your exam. Okay. Next one, are the crystals of salts really dry? So here, so crystals of the salts. So commonly, you know, sodium chloride, table salt, common ಆಗಿ ನೋಡಿರ್ತೀರಾ ಅಲ್ವಾ? So are they really dry? So not sodium chloride, some other salts, are they really dry, or they contain some water content in that? So that we have to check. Okay, I hope the concept is clear. So the salts, they looks dry, right? If you touch any salt, it is dry. So are they really dry, or is there any water molecules are present in that salt? That we have to check. Okay. I hope that concept is clear. That topic is clear. So to check that, so we have to perform one experiment. So what is that experiment? Heat a few crystals of copper sulfate in a dry boiling tube. Okay. So you have to heat the few crystals of copper sulfate. So here, what is the color of the copper sulfate? That is commonly blue in color, right? The copper sulfate crystals should be taken in the test tube. So this is the test tube and burner. So using this test tube, just put the copper sulfate crystals, that is usually light blue in color, sky blue in color, right? So when it is heated, so if you heat that copper sulfate crystals, so you can observe the change in the color. Okay, so what is the color? So color ಏನಾಗಿರುತ್ತೆ ಅಲ್ಲಿ, ಕಲರ್ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ. ಐ ಥಿಂಕ್ ಇಟ್ is in the black brown color ಅಲ್ಲಿ ಅದು ಚೇಂಜ್ ಆಗಿರುತ್ತೆ when it is heated. So again when you add the 2 to 3 drops of water to that sample, again copper sulfate solution is obtaining the color after heating. Okay, so what happened in this reaction, what happened in this experiment ನೋಡಿ, ಒಂದು ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅನ್ನ ತೆಗೆದುಕೊಳ್ಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಕಾಮನ್ಲಿ ಇನ್ ಸ್ಕೈ ಬ್ಲೂ ಕಲರ್. ಸೊ ಕಲರ್ ಏನಾಗಿರುತ್ತೆ, ಈ ರೀತಿಯಾಗಿರುತ್ತೆ. ವೆನ್ ಇಟ್ ಈಸ್ ಹೀಟೆಡ್, ಸೊ ಹೀಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಬ್ಲಾಕ್ ಕಲರ್ಗೆ ಟರ್ನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಸ್ಟೆಪ್. When you add 2 to 3 drops of water, when you add 2 to 3 drops of water and heat it, again it takes its original color. When you add the water, 2 to 3 drops of water, it takes the original color. So what happened in this experiment? ಹಾಗಾದ್ರೆ ಏನಾಯ್ತು ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಅಲ್ವಾ? Here a copper sulfate crystal which seems to be dry contain water of crystallization. ನೋಡಿ, ಕಾಪರ್ ಸಲ್ಫೇಟ್, ನೀವು ಕಾಮನ್ ಆಗಿ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಅನ್ನ ನೋಡಿದ್ರೆ ದಟ್ ಲುಕ್ಸ್ ಡ್ರೈ. ಸೊ ಈಗ ನೀವು ಆ ಸಾಲ್ಟ್ ಅನ್ನ ಟಚ್ ಮಾಡಿದ್ರೆ ಏನಾಗಿರುತ್ತೆ, ಡ್ರೈ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಬಟ್ ಇಟ್ ಕಂಟೈನ್ ವಾಟರ್ ಆಫ್ ಕ್ರಿಸ್ಟಲೈಸೇಷನ್. So what is this water of crystallization? Very important, water of crystallization. When we heat the crystal, this water is removed. So ನಾವೇನ್ ಹೀಟ್ ಮಾಡ್ತೇವೆ ಅಲ್ವಾ, ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಅನ್ನ ಹೀಟ್ ಮಾಡಿದಾಗ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇವಾಪರೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಕಲರ್ ಇಸ್ ಚೇಂಜ್ಡ್. ದ ರೀಸನ್ why the color changed when we heat the copper sulfate, because the water molecules are removed. Okay, if you moisten the crystals again, if you add the water again, you will find the blue color of the crystals reappear. Again the color is reappear. The water of crystallization is fixed number of water molecules present in one formula unit of the salt. What is water of crystallization? Very important. So water of crystallization is fixed number of water molecules present in one formula unit of the salt. Here 5 water molecules are present in one formula unit of the copper sulfate. ಇಲ್ಲಿ ನೋಡಿ, copper sulfate ಅನ್ನ ಹೇಗೆ ಬರಿತೇವೆ, CuSO4 5H2O. So here 5 molecules of water of crystallization present in the salt. Then here sodium ಕಾರ್ಬೋನೇಟ್, ದಟ್ ಈಸ್ ವಾಷಿಂಗ್ ಸೋಡಾ. ವಾಷಿಂಗ್ ಸೋಡಾದಲ್ಲಿ ಇಲ್ಲಿ 10H2O ಅಂತ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅಲ್ವಾ. ಸೊ ದಟ್ ಈಸ್ ದ ವಾಟರ್ ಆಫ್ ಕ್ರಿಸ್ಟಲೈಸೇಷನ್. ಇಲ್ಲಿ 10 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ವಾಟರ್ ಇರುತ್ತೆ. ನಾವೇನ್ ಡ್ರೈ ಇದೆ ಅಂತ ಅನ್ಕೊಂಡಿರ್ತೇವೆ ಅಲ್ವಾ, ಸೊ ಅದು ಡ್ರೈ ಇರಲ್ಲ, ಬಟ್ ಅದರಲ್ಲಿ ಏನಿರುತ್ತೆ, ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ದ ವಾಟರ್ ಆಫ್ ಕ್ರಿಸ್ಟಲೈಸೇಷನ್. ಓಕೆ, so what we can say, some salts they contain the water of crystallization. Already some molecules of water present in the formula of that salt. Okay, here one other salt which possesses water of crystallization is gypsum. So gypsum, how many water molecules are present here? Anybody, how many water molecules are present here? Just write down in the comment box. How many water of crystallization present in the gypsum, that is calcium sulfate, CaSO4 2H2O. ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳ್ಬೋದಾ? Not 10. Yes, 2. Very good. Not 4. 2 is the correct answer. Two molecules of water of crystallization present in the gypsum. Okay. Yes, that is correct. Calcium sulfate, in calcium sulfate, 5 water molecules are present. In sodium carbonate, 10 water molecules are present. Okay. So, ಈ ತರ questions ಅನ್ನು ಕೂಡ MCQ ದಲ್ಲಿ ನಿಮಗೆ ಕೇಳ್ತಾರೆ. Then plaster of Paris. So the common name is plaster of Paris. Okay, I hope you heard this word, plaster of Paris. On heating the gypsum at 373 Kelvin. So when we convert the 373 Kelvin in degree Celsius, so how many degree Celsius it is? Anybody? Just write down in the comment box. On heating the gypsum at 373 Kelvin. So, right. So, that is given in the Kelvin. So, if you convert this temperature in degree Celsius, how much degree Celsius it will be? Is anybody? So, that is in the ninth standard, right? It loses the water molecules and becomes calcium sulfate hemihydrate. So, when we heat the gypsum, so that is converted into calcium sulfate hemihydrate. Yes, very good. That is 100. Very good. 100 degrees Celsius. So when we heat the gypsum at 373 Kelvin, so 373 Kelvin, that is 100 degrees Celsius. Okay. So you should know this in degree Celsius also. It loses the water molecules. When we heat the gypsum, it become calcium sulfate hemihydrate, that is CaSO4 half H2O, that is called as calcium sulfate hemihydrate. Okay, so this is called as plaster of Paris. What is the chemical name of the plaster of Paris? ಇದನ್ನ MCQ ದಲ್ಲೂ ಕೂಡ ನಿಮಗೆ ಕೇಳ್ತಾರೆ. What is the chemical name of the plaster of Paris? That is calcium sulfate hemihydrate. Calcium sulfate hemihydrate. So the substance which doctors use as a plaster for supporting the fractured bones in the right position. Common agi medical field ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ ಡಾಕ್ಟರ್ಸ್ ಫ್ರಾಕ್ಚರ್ ಆಗಿರೋ ಬೋನ್ ಅನ್ನ ಸರಿ ಮಾಡ್ಲಿಕ್ಕೆ ಅದನ್ನ ಸಪೋರ್ಟ್ ಆಗಿ ಹೊರಗಡೆಯಿಂದ ನೀವು ನೋಡಿರ್ತೀರಾ, ಕೈ ಅಥವಾ ಕಾಲು ಫ್ರಾಕ್ಚರ್ ಆದಾಗ ವೈಟ್ ಕಲರ್ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನ ಹೊರಗಡೆಯಿಂದ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ ಅಲ್ವಾ. ಸೊ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ plaster of Paris. Plaster of Paris is a white powder, and on mixing with water it changes to gypsum, once again giving the hard solid mass. So plaster of Paris, that is the powder. Okay, so when it is mixed with the water, it converted into hard solid mass, so that is called as the gypsum. Okay, when we heat the gypsum, it becomes plaster of Paris. So here the chemical reaction, so that is between the when plaster of Paris is treated with the water, how it forms the gypsum here. CaSO4 half H2O, that is the plaster of Paris. When it is treated with the water, CaSO4 half H2O, when it is treated with the water, it forms the calcium sulfate and the water. So that is calcium sulfate, that is 2H2O, means that is gypsum. Okay, so gypsum formula you know calcium sulfate, that is CaSO4 2H2O. Okay, so this reaction is very very important. Idanna keltare, very important for your exam. Okay, gypsum, that is the substance, chemical substance. Okay, yes, so this stop is completed here. So here we complete the chapter acids, bases and salts. Okay, so ಇಲ್ಲಿಗೆ acids, bases and salts chapter complete ಆಗಿದೆ. If you have any doubt, you can ask in the comment box. Otherwise, in the next part of this chapter, we are going to discuss some questions related to this chapter. Okay, ಏನಾದ್ರೂ doubt ಇದೆಯಾ? I will give you 2 minutes. Please ask in the comment box. Okay. Yes, I'm checking the chat box. If you have any doubts, you can ask. Okay. Okay, no, ma'am. No, ma'am. Okay. What is gypsum? So, gypsum, Nagaraju. Okay. What is gypsum? Gypsum is the substance. Okay. So, ಅದೊಂದು substance. ನಾವು ಹೇಗೆ ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಅಂಡ್ ಕಾಂಪೌಂಡ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅಲ್ವಾ? ಈಗ ಕ್ಯಾಲ್ಸಿಯಂ ಸಲ್ಫೇಟ್ ಏನು ಅಂದ್ರೆ ನಾವೇನ್ ಹೇಳ್ಬಹುದು? ದಟ್ is the substance. Calcium sulfate, that is the substance ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. Okay. No doubt. No doubt. Okay, ma'am, send the question and answer. Okay, I will discuss the question answer here. After that, I will send that. Okay, don't worry. What is gypsum used for? Yes, gypsum, plaster of Paris is used for many purpose. Okay, so plaster of Paris ಏನಾಗುತ್ತೆ ಗಟ್ಟಿ ಆದಾಗ ವಾಟರ್ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗಿ ಗಟ್ಟಿ ಆದಾಗ ಜಿಪ್ಸಮ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಪ್ಲಾಸ್ಟರ್ ಆಫ್ ಪ್ಯಾರಿಸ್ ಅನ್ನ ಏನ್ ಮಾಡ್ತಾರೆ, ಡಾಕ್ಟರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಮೆಡಿಕಲ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಅಂಡ್ ಈ ಕೆಲವೊಂದು ಆಟಿಕೆಗಳನ್ನ ತಯಾರು ಮಾಡ್ಲಿಕ್ಕೆ ಇರ್ಬೋದು. ಸೊ ಟಾಯ್ಸ್ ಆರ್ ಸಮ್ ಏನ್ ಹೇಳ್ಬೋದು, ಟಾಯ್ಸ್ ಆರ್ ಸಮ್ ಅದರ್ ಸ್ಕಲ್ಪ್ಚರ್ಸ್ ಆರ್ ಪ್ರಿಪೇರ್ಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಪ್ಲಾಸ್ಟರ್ ಆಫ್ ಪ್ಯಾರಿಸ್. ಎಸ್. Okay. Yes, most of the students, so they don't have any doubts. So I will move to the next part of this chapter. So that is discussion of question answer. Okay. So let us discuss the some question answer on this chapter. So a solution turns red litmus to blue. Its pH is likely to be option A 1, option B 4, option C 5, option D 10. Yes, what is the correct answer? Please write the correct option in the comment box. Yes. So red litmus that turns to blue color. So that should be, the solution should be base, right? Because when the litmus paper that is dipped in a solution, in a basic solution, the litmus paper that changes to red to blue. So the pH likely to be 1, 4, 5 means 1 to 7. 7 is the neutral, to 6 that is acid, right? But option D 10. So 10 means that is the basic solution. So option D, that is the basic solution. Okay. Yes, 10. Not 1, 4, 5. So these A, B, and C not correct. Option D is the correct answer. Next question. A solution reacts with crushed eggshells to give gas that turns lime water milky. The solution contains. A solution reacts with the crushed eggshells to give the gas that turns the lime water milky. Here, which one the solution contain? What it contains, the solution? What is the answer for this question? So HCl, when the HCl reacts with the eggshells, which releases the carbon dioxide. So ಅದು ಏನ್ ಮಾಡುತ್ತೆ, carbon dioxide ಅನ್ನ release ಮಾಡುತ್ತೆ. And this carbon dioxide that turns the lime water milky. Okay. So that turns the lime water milky. The correct option is option B, HCl. Next question. 10 ml solution of sodium hydroxide is found to be completely neutralized by 8 ml of given solution of HCl. If we take 20 ml of same solution of sodium hydroxide, the amount of HCl solution, so that is for the same solution as before, required to neutralize it will be option A 4 ml, option B 8 ml, option C 12 ml, option D 16 ml. Here 10 ml of sodium hydroxide, 10 ml of NaOH is used to neutralize the 8 ml of HCl. Okay, 8 ml of HCl. So if we take 20 ml of same NaOH solution, so here I am taking the same solution of sodium hydroxide. How much amount of solution will be required to neutralize it will be? So same solution here 8 ml, 10 ml sodium hydroxide. So here 20 ml. So that is doubled. So here 8 ml. So here I will write 16 ml HCl is required. So option D 16 ml. I hope this is clear. 16 ml. Yes, very good. Many students are writing the answer not 12 ml, 16 it will be. Next question. Which one of the following types of medicines is used for treating the indigestion? Indigestion or irritation in the stomach that is due to the acid. Okay. Option A, antibiotic. Option B, analgesic. Option D, antacid, antiseptic. Yes, which one is the correct answer? For indigestion, don't say eno. eno ಅಂತ ಹೇಳ್ಬೇಡಿ. Antacid, yes. Many students are writing antacid. Yes, Vaibhav is very good. Antacid. Option C, antacid is the correct answer. Next question. Write word equation and then balance the equation for the reaction taking place when dilute sulfuric acid reacts with zinc granules. When dilute sulfuric acid, that is the HCl, okay. Hydrochloric acid reacts with the zinc granules Zn, so which forms the zinc sulfate ZnSO4 plus hydrogen gas is released, right? Here hydrogen gas is also released. You have to balance this reaction. Here hydrogen 2. Here also I will add 2 hydrogen. Sorry, H2SO4, not HCl. Sorry. Sulfuric acid, okay, not hydrochloric acid. H2SO4. Sulfuric acid is used. Zinc sulfate, 2 hydrogen. Yes, this is already balanced. You should write the physical state of this reaction, reactant and the product. Okay. So aqueous, solid, aqueous and hydrogen, that is the gas. So here when the acids react with the metals, they forms the salt and hydrogen gas. Zinc sulfate, that is the salt, and hydrogen, that is the gas. Hydrogen gas is released in this reaction. Dilute hydrochloric acids reacts with magnesium ribbon. Dilute HCl when hydrochloric acid, when it reacts with the magnesium, that is the metal, right? Acid when reacts with the metal which forms the salt, that is MgCl, that is magnesium chloride plus hydrogen gas is released. So that is same when the acids react with the metal, that forms the salt and hydrogen gas. Salt ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅನ್ನ ರಿಲೀಸ್ ಮಾಡುತ್ತೆ ಅಲ್ವಾ, ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಸೇಮ್ ರಿಯಾಕ್ಷನ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್, ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು. ಸಾರಿ, next one, dilute sulfuric acid reacts with aluminum powder. Here, acid when react with the metal, it also forms the salt and hydrogen gas ಅಲ್ವಾ. ಅಲ್ಯೂಮಿನಿಯಂ ಸಲ್ಫೇಟ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅನ್ನ ರಿಲೀಸ್ ಮಾಡುತ್ತೆ. Here, dilute sulfuric acid, that is H2SO4, H2SO4, aluminum powder, that is Al ಅಲ್ವಾ. Aluminum, that is the metal. What it forms? It forms the aluminum sulfate, that is Al2 SO4 thrice plus hydrogen. Okay, just I have written the 3 hydrogen. You have to balance this. Just balance the reaction. You know how to balance the chemical reaction. Sorry for the inconvenience. Yes, next one. Dilute hydrochloric acids reacts with iron fillings. Here, dilute hydrochloric acid, that is the acid, right? HCl, when reacts with the iron fillings, iron means Fe, which forms the FeCl2, that is iron chloride, FeCl2 plus hydrogen gas is released. Just try to balance this reaction. Yes, 2 hydrogens, here also 2 hydrogens I will add, and 2 chlorine, that is also balanced, Fe, that is also balanced, and here AQ, aqueous, and solid S, and FeCl2, that is the aqueous, FeCl2, and hydrogen, that is the gas, right? So this is the balanced chemical reaction. So here hydrogen gas is formed when the acids react with the metal. Okay, so when the acids react with the metal, they forms the salt and hydrogen gas. Based on this, these all reactions you have to form. Next one, compounds like alcohols and glucose also contain the hydrogen but are not categorized as acids. Described an experiment activity to prove it. Okay, so this activity already we have studied, right? Here, glucose, what is the chemical formula? C6H12O6 is the glucose chemical formula. And alcohol, it also contain, for example, C2H5OH. So it also contain the hydrogen, that is H. H is present. So why they are not considered as acids? Why they are not considered as acids? That you have to prove using the activity. So just briefly, I would like to explain that experiment. So what is that experiment? So you have to take the beaker. Okay, so in that beaker, so you have to use the electrodes that should be connected to the battery, and one bulb should be connected in that, and the switch. Okay, like this the connection will be. When you use the HCl, HCl, hydrochloric acid, aqueous. Okay, when you use this hydrochloric acid, when the current passed through these electrodes, so you can see the bulb is glowing. Okay, so bulb ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಇಲ್ಲಿ ಲೈಟ್ ಫಾರ್ಮೇಶನ್ ಆಗಿರೋದನ್ನ ನೀವು ನೋಡಬಹುದು ಅಲ್ವಾ. But when you use the glucose or alcohol, then just change this solution with the alcohol or the glucose. So then the bulb is not glowing here. So what is the reason behind this? So this is the activity that you have to explain. So what is the reason behind this? So this HCl, which forms the H plus ions and that are responsible for the conduction of the electricity, but these alcohols and glucose, they are not able to form the H plus ions, even though they contain the hydrogen, but they are not able to form the H plus ions. So that is the main reason. So this activity you have to explain. Take the solution of alcohol, glucose in a beaker and cork and fix the two nails on the cork up to the end. Connect the nails to the terminals of the 6-volt battery through the bulb and the switch and switch on the current. Then you will see the bulb that is glowing. Okay, so the current passed through the circuit, means H plus ions are present, but these H plus ions are not present in the alcohol and the glucose. So that is the reason. So they are not considered as the acids. They are not able to form the H plus ions. So for that reason, it is considered as they are considered as not acids. Okay. Next one. Why does distilled water not conduct electricity whereas rainwater does? Why does distilled water not conduct electricity whereas rainwater conduct? Okay, what is the reason behind this? Distilled water is pure form of water. So this do not contains ions. Distilled water, they do not contain any ions. So no electricity flows. For the electricity, so it requires the ions. H plus ions are required, but H plus ions are not there. So for that reason, but rainwater contains the dissolved acids and the salts. Dissolved acids and the salts present in this. So hence rainwater conduct the electricity. Next question. Why do acids not show acidic behavior in the absence of water? So this question also I have discussed, right? Why do acids not show the acidic behavior in the absence of water? So water absence ಅಲ್ಲಿ ಯಾಕೆ acidic behavior ಅನ್ನ show ಮಾಡಲ್ಲ ಅಲ್ವಾ? So here acids do not show the acidic behavior in the absence of water because dissociation of hydrogen ions not formed. Because when the H plus ions are formed, then only they are able to conduct the, they show the acidic property. But in the absence of H plus ions, so here, so that is not possible in the, in the absence of water, the H plus ion formation is not possible. For example, HCl gas. HCl gas, it is not able to turn the blue litmus to red, right? So HCl gas, that is not able to show the acidic behavior. But when HCl is the aqueous solution, so which is in water, then it is able to show the that is able to show the acidic character because which forms the H plus ions. So that is very important. Yes, next one, please note down this question. 5 solutions of A, B, C, D and E when tested with the universal indicator showed the pH as 4, 1, 11, 7 and 9. Okay. So A, that is showing the 4, the pH is 4. B solution, that is showing the pH 1. And the C solution, that is showing the pH 11. And D and E. Okay, the pH is 9. which solution is neutral? Here, which solution is neutral? The solution which is having the pH 7, that is the neutral solution, that is D. D is the neutral. And strongly alkaline. So strongly alkaline means which is more than 7. So which is nearer to 14. So 14 ಗೆ ಹತ್ರ numbers ಇದೆ, that is strongly alkaline, like 11, 12, 13, 14. So these all are strongly alkaline. Here which one is alkaline? The solution C is strongly alkaline in this given solutions. Then strongly acidic. So below 7, that is from 1, 2, 3, 4. So these all are, so they are strongly acidic. Below 7, acid, commonly we considered as acids, but near to 1, 2, 3, so that is the strong acid. Here which one is the strong acid? The solution which is having the pH 1, that is B. B is the strongly acidic. And weakly acidic, which is near to 7. 7 is the neutral, but which is near to 7, so that is called as the weakly acidic. So here we can consider 4. Solution A. Solution A is the weakly acidic. Okay. So yes, this we have arranged. Now, what you have to do? Which one is weakly alkaline? Weakly alkaline solution is the 9th one, that is E. Weakly alkaline, that is the solution E. So here what you have to do, next step is arrange the pH in the increasing order of hydrogen ion concentration. Increasing order of hydrogen ion concentration means the bases, they have the more OH minus ions, means less H plus ions, right? So you have to arrange first bases, after that weak acids, then the strong bases. Strong bases, they have the more hydrogen ions, alva. So illen ಮಾಡಬೇಕು ಅಂದ್ರೆ increasing order ಅಲ್ಲಿ ಅಂದ್ರೆ ಕಡಿಮೆ ಇರೋ H plus ions ಅನ್ನ arrange ಮಾಡಬೇಕು, then which are containing the more hydrogen ions. Okay, so yes, which one is the first one? That is having the pH 11, C. Then 9, E. Then it is the neutral, that is 7, D. Next one, A, the solution A. And next one, solution B. Okay, yes, this is the increasing order of hydrogen ion concentration, that is H plus ion concentration. Okay, yes, I hope this question is clear. Yes, next one. Equal lengths of magnesium ribbons are taken in the test tube A and the B. So same length of magnesium ribbons are taken. Hydrochloric acid is added to the test tube A. So one test tube that contain the magnesium ribbon. So in that test tube, hydrochloric acid is added, and in another test tube, acetic acid, so that is CH3COH is added to the test tube B. Amount and concentration taken for the acids are same concentration of acid, and the amount is also same. In which test tube will fizzing occur vigorously and why? Yes, anybody? Here, the fizzing will occur more vigorously in test tube A. So why in the test tube A? Because A test tube that contain the hydrochloric acid, the test tube A that contain the hydrochloric acid, this is because hydrochloric acid is strong acid compared to the acetic acid. So hydrochloric acid anna strong acid anta consider ಮಾಡ್ತೇವೆ ಅಲ್ವಾ? So acetic acid is the weak acid, that is having the pH nearer to 5 to 6. Okay, so the reaction between magnesium ribbon and the strong acid is faster. So magnesium metal and the strong acid, the reaction is faster compared to the magnesium and the acetic acid. So that is the reason. Okay, Next one. Fresh milk has the pH of 6. Okay. How do you think the pH will change as it turns into curd? So you know that the milk that convert into curd. So the fresh milk pH is 6. So how the pH will change when it changes into curd? The Here, the pH of milk is 6. As it changes into curd, the pH will reduces as during the curd formation. So curd formation ಆಗ್ಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ? The lactose sugar, so that is present in the milk. The lactose sugar that convert into lactic acid, okay? The sugar that converted into lactic acid. So therefore, the curd is acidic in nature. So the curd is more acidic in nature, not 6. So 6 is nearer to neutral, right? But the acids, the curd that contain the lactic acid, so that is more acidic compared to this milk. The acids present in it decreases the pH. The lactic acid that decreases the pH. pH ಏನಾಗುತ್ತೆ 6 ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. Okay. Yes. So dear students, till now we have discussed 11 questions. We have completed the chapter, and after that related some questions related to this chapter we have discussed. I hope this class is very useful for you people. If you have any doubt, you can write down in the comment box. Okay. And don't forget to chat that how was the class. Okay. Yes. Thank you, dear students.